Here's something that trips up almost every language. Is 0.1 plus 0.2 equal to 0.3? Kaappi says false, and it's not wrong. Floating point simply can't hold those values exactly. Watch what Kaappi gives you instead. 1 divided by 3 isn't 0.333 forever. It's 1/3, and Kaappi keeps it as 1/3 exactly. So a tenth plus 2/10 is exactly 3/10, the thing floating point couldn't do. And they add like proper fractions. A half plus a third is 5/6. A third times 3 is exactly 1, a whole number again, with nothing lost on the way. Integers grow as large as they need to. 2 to the 100th power, Kaappi just prints the whole thing. Factorial of 50, 60 odd digits, exact to the last one. No overflow, no wrapping around to nonsense. When you do want a decimal, you ask for one. The square root of 2 is irrational, so it comes back as a float. The square root of 25 is exactly 5, and exact to inexact turns any exact number into its decimal. A third becomes 0.33, and so on. There's exact integer math too. Exact integer square root of 17 gives 4, remainder 1. The whole answer, no floating point anywhere near it. And numbers convert cleanly to and from text in any base. 255 in hexadecimal is FF, and Kaappi reads it straight back the other way. So, exact by default. Money, counts, fractions, anything that has to be correct, Kaappi keeps it exact. Reach for floating point only when you genuinely want an approximation. Most languages make that call for you. Kaappi hands it back. Thanks for watching. Subscribe for more Kaappi.